Question number 18. In the 16th century, the astronomer Tycho Brahe made measurements of stars in the night sky. He measured the angle of a range of stars above the horizon. For each star, he measured the angle over a period of time to determine a parallax effect. Describe how a stellar parallax is used by astronomers. So basically, this concept is used to measure the distance between the star and the sun. Okay, so how this is being using? So for that, I have taken a picture from our textbook itself. So basically, for getting 100% mark, we must draw a figure. So what is actually the concept? After drawing the concept, rough schematic sketch, what all points we should include here? One thing we should include is the star is viewed from two positions. That means these two positions are actually the opposite sides of the diameter of the Earth's orbit about the sun. So this is actually happening by viewing from two positions at a 6 months interval, correct? Then, so what happens? At that moment, the parallax effect will really, we can apply here. How? The change in the angular position of the star against the backdrop of the distance or the fixed stars is measured. So here in this figure, that is actually 2 theta. To apply this concept, we must know the distance between sun and the earth. So the distance between sun and earth is actually 1 light year, correct? Not light year, I mean 1 astronomical year. That is already known for us. So if you know this distance, you can construct a right angled triangle. So you can easily calculate the distance between the sun and the star. That is D. How we can apply the concept of trigonometry, and you can use this idea to find the distance. How? Because tan theta is opposite side by adjacent side. So D is equal to R over tan theta. Theta means it is the half of the angle measured in the 6-month interval time. Clear? So shall we write that points here? So we should clearly draw this figure. Then after that, we should include some points, 3 valid points, and the figure will give you 4 marks. So what are the points we should include here? The star is viewed from two positions at the 6 months interval. So in this 6-month interval, actually what is happening? We are actually viewed from opposite ends of the diameter. Clear? That you can keep in your mind. Then second point we should include is the change in angular position. The change in the angular position, that is this 2 theta, correct? Of the star against backdrop of distant stars is measured. This is the background stars. Now what we should do? Trigonometry is used to calculate the distance to the star D. That you can show here. Refer figure 1 and figure 2. This is figure 1. This is figure 2. This is actually the half of this. So what we can do? We can take tan theta is equal to R by D. That implies us D is equal to R by tan theta. So we should keep this one thing in our mind. What is that? The radius of the Earth orbit about Sun, and that is equal to 1 astronomical unit. That also keep in our mind. Okay, so that's about this first part of this. Move to second part of question A. Tycho Brahe concluded that Earth was motionless at the center of the universe, as he was not able to detect any stellar parallax. Suggests why he was not able to detect any stellar parallax. So 1 mark question. So how will you answer this? So we can say that stars were too far away for change in angular position to be measured. So we can say stars were too far away for change in angular position to be measured. So what happens? So that when the distance is very large, it becomes very difficult to measure this parallax angle. That's a very small angle. So it's not possible to detect any stellar parallax. Move to the B part. Tycho Brahe was one of the first astronomers to observe a supernova. Supernovas are used as a type of standard candle. State what is meant by a standard candle. So what is the meaning of standard candle? We can say a stellar object of non-luminosity. That is known as a straightaway question. So we can say a stellar object of non-luminosity. Move to second part of this. Describe how standard candles can be used to determine the distance of nearby galaxies. How we will describe this? Describe how standard candles can be used to determine the distance nearby galaxies. So here, what we should do? First of all, identify or locate a standard candle in the nearby galaxy. Then measure the intensity of radiation from the standard candle. Then what we should do? We should use the inverse square law to calculate the distance. How will you calculate the distance? Using the equation intensity is equal to luminosity by 4 pi d square. So we'll write that points. Identify standard candle in nearby galaxy. Then what we should do? Measure the intensity of radiation. Because if you identify the standard candle, we know the luminosity, right? Then measure the intensity of the radiation from the standard candle. Then we know these two things now. We know L and we now know intensity. Then we can use this formula of intensity. Intensity is luminosity by 4 pi d square. So from this, d square is luminosity by 4 pi I. So the distance is equal to root of L by 4 pi. Using this, we can calculate the distance nearby galaxies. Hope you got the idea.